three graphs, and the first one I'll say a table makes the most sense here, X and Y, and it's good for values less than 0, but you start at that value anyway, and you maybe indicate that it's an open circle there, even though it's not included. It's kind of like right up to that, and then you just have to choose a couple of values smaller than it, so maybe like -1 and -2, and you're putting those into the function, that X plus 3.
Okay.
Okay, so you'll get 0 plus 3 is 3, -1 plus 3 is 2, -2 plus 3 is 1. You know, we've got something here. And I think it makes sense to graph as you go. I don't think it's a good idea to wait till the end. I think that could be, you know, very confusing, especially under stressful test situations. So what I see here is a good start here on the right. I like what I see here. You got 0, 3, -1, 2, and then -2, 1. Very good that you've got you know, arrows there, super important. Now, if X is 0, Y is 5. So that's a point right up there. You got that. I like that. And then for the other one, same thing. You're going to make another table. X, Y. You start at 0 though, but it's good to indicate that it's an open circle because of that greater than. Give it a point or 2, and looks like you've got it -1, +1, and +3. So, I mean, I don't really like your graph here. I'd like to see it up a little higher, but overall pretty good. I mean, probably, 9 out of 10 on that, maybe 19 out of 20, pretty good. Like it's kind of hit everything on there. So any questions on that?
No. So you just graph like all those points that we just got from the table to make it more
Exactly.
accurate. Okay.
Exactly. And I strongly recommend the table. You'll notice here, like I went kind of backwards on this one because you kind of create that, whatever that edge point is, you just move away from it. Whatever the edge point is, you move away from it. So sometimes the values are getting smaller, sometimes they're getting larger. Be sure to indicate the right thing. If they have a third one in the middle that's actually a function, you just go up to the two endpoints.
Okay.
All right. So number two, math, you go forwards, you go backwards. Number 2 is going backwards. They give you the graph and then they say, come up with the equation. So what's easiest to do though, the easiest part of this is to figure out the domain of this. So, it's some sort of function. Domain goes over here on the right. So there's this, if you almost want to like break it up into 3 parts here, and then with a little table, you've got the domain stuff on the right, functions in here. So the domain is usually easiest. The one on the leftmost one, it goes from -4 to -1. So -4 to -1. Notice it includes -1. There's a filled in bubble there, but it does not include the other one. So we'll get to what it actually is, but I think, low hanging fruit, you've probably heard that. You try to do the easy stuff first. Domain is definitely easier than writing the function. The other one goes from -1 to 2. We're looking at the X values. -1, less than X, less than or equal to 2. Filled in on the right for the same reason as the previous one, open bubble on the left. And then the last one is X greater than 2. All right, so I recommend doing that first, totally up to you if you adopt that strategy. The next thing is to come up with the equations. And we've got a line, looks like a quadratic, and then a line. The first line is a straight line. And the equation of a straight line is always y equals a number. Y equals a number, but because it's function notation, they just want the number. They just want to know what the number is. So it's a little bit awkward, but you just put a 1 there. And I guess your class uses if, so we'll put the word if there. All right. This other line to the right is probably next easiest to do. Now, one thing you can do is just sort of extend it. I know it's kind of weird because of the way the picture came in that folded, but you extend it to get the the y-intercept or the b value. Like it's nice to know that it hits there because the easiest form of a line is mx plus b. The b value is -4, even though it doesn't hit there, you still like presume that it does. And then you just need the slope to go along with it. Can you tell me the slope of this line?
Is it across to and up to?
Yeah, or up one, right one. So the slope is 1. So it's 1x minus 4. The 1 is the slope. The minus 4 is where it hits.
Okay.
All right. The quadratic is by far the most difficult. Keep in mind that, I mean, they're not testing you on functions, so it doesn't have to be like, it's not going to be this really exotic thing. It's just going to be some sort of quadratic. And the base one, is x squared. How would you say that this differs from x squared? Besides, I know it's missing stuff, but like, is it up, down, left, right? What do you see?
It's going up.
Right, the whole graph. I'm talking about transformations. I'm talking about
Oh,
like normally x squared starts at the origin, but this one does not. Right,
uh,
it's starting, its vertex is down a little
uh-huh.
ways.
Um, well, it's just like moving to positive, I guess.
This one is a transformation down one. Like
Oh,
the vertex normally is at the origin, but you can see it's moved. I don't know how to show it real well. I know it's down there. So it's an x squared minus 1.
okay.
And that's it. Now, if you're thinking about like how to get the most points, it's start with the domain and then do the easy functions first. And then if you can, or if you're struggling, try to at least put down what it kind of looked like. Like if it was a V, it'd be an absolute value. We don't really know what it has there. Okay, we can now also do the domain and range.
Mm-hmm.
I'm gonna just reset the problem here with those things. So domain is it really it comes from the graph, but after you have the piecewise function, you can kind of use that. It's up to you, but you see it starts here at the left. It starts here at -4. It goes to -1, but and you might say, was it undefined there? Yeah, it is right there where my cursor is, but not up here. So it's actually okay. And then you keep going, kind of same scenario. Like you might think, oh, it's undefined, but really it's defined up there, just isn't down here. And then you keep going. So the domain is actually all the numbers greater than -4. Are you guys using set builder or interval notation?
Interval.
Okay, so that's the old way of doing it. You have to say -4 to infinity. Right. And if you don't like that, like you might say, well, I just don't think that's, you start by going back here, -4 to -1, -1 to 2, bigger than 2. Like everything is, there's coverage. You don't have to worry about like a gap. Don't worry about the vertical
Mm-hmm.
gaps. You're looking for the horizontal ones. Okay. Now
Why wouldn't it?
range, good.
Why wouldn't it be all real numbers?
It appears to end right there, unless I'm missing something. Like this
Okay.
just looks like the axis, looks like it just stops right there.
Okay.
Like if this was an arrow going up forever to the left, then it would be all real numbers.
Okay.
All right, the range, unfortunately, is more complicated. You're looking for the smallest y value, and it's right here at -2. All right, do you see that? Like it's
Yeah.
at -2, but you see these gaps there. There's a gap there. Maybe you see another gap here, but they're filled in. Like, and when I say filled in, you're trying to like, this doesn't work real well, the format. haven't had to explain this in a while, but it's like there's this part of the line right here that makes up for the gap right there. And then this part of the line here makes up for the Y gap there. And the fact that this goes up forever means that every Y value starting at -2 is possible.
Oh, okay,
So
yeah.
so the range, I'm glad I don't have to explain more than that, is all the numbers from -2 to infinity, but not including infinity. They're not included with parentheses. Right. And then this mid behavior, this is kind of leading you to calculus and limits. They want you to say, okay, as x approaches 2 from the left, and I'm not sure how you guys are doing that, but like from the left means kind of in this direction with the red. They want to know the Y value. And then there's also from the right. Does that at all sound familiar?
Yeah.
Okay. This is not the correct notation, but you didn't say you were in calculus yet, so I can't really use the proper notation for this. And but what you have to see is that, okay, I'm going to, like, I pick out where 2 is, and I have to approach it from the left and from the right. It's like when two people are lost, it's like, what do you see? And you're like, I see a 3, and you're like, no, I see a -2, and so on. So there's a little more to this. You have to say what the Y value is approaching or what the function is approaching. So as you approach x from the left, f of x is 3. Okay, and it's like what the number is that you're approaching is 3. And then from the other direction, from the green, from the right, it approaches -2.
Is that it for it?
That's it for that. Yeah.
Oh, okay. Not bad.
Okay. Any questions on that before we move to number 3?
No, I don't think so.
Okay. Mainly, I guess it's like, do you think you could replicate this on your own? When I'm not there, because I can't be there taking your test. Why did I? All right. We'll hold 12 gallons of gas. Okay, so let's see here. Aaron buys gas for 275 a gallon. Buys more than 10 gallons, that's only 250 a gallon. Okay. All right. So this first part is almost correct. One of the issues with this, and your instructor would definitely not be okay with this, is you can't buy negative gallons of gas. Like, it has to stop at some point. And the other issue is that if you don't buy any gas, you don't pay anything. So it has to start here at the origin.
Okay.
So a couple of points would help. Like you were kind of asking me earlier, like you were asking me earlier, and a few points would help. So X and Y, it's like, okay, when X is 0, Y is 0. If you buy 2 gallons of gas, that's $5.50. Boy, wouldn't it be nice if gas were only $2.75? It's certainly not that now. So this goes from 0 to 10. Okay. And then you could add some more points, like 4 gallons would be $11. And these are the nice points that you can graph. So when you're graphing this, you're not, you're kind of trying to figure out, okay, where do these go? And you're kind of right there. It just needs to be a little bit cleaner. And then, yeah, if you buy exactly 10 gallons of gas, kind of that edge point, it is $27.50.
Mhm.
Okay. But it's like, well, wait, what will happen if you buy 12 gallons of gas? Now, this is correct, what you have, but you can't buy your like you say here, it has to go from 10 to 12. Okay. And it actually does not, like you say, this is perfect. It's you assume that you have to get to 10 gallons to get the better price. So you've got here 25 and then 30. So this is great. All right, so you've got your graph, and then things like that. So is that okay? So basically, I'm just asked that the arrow here is the only kind of bad thing of this. The rest of it looks okay. You probably want to put C of G and then parentheses here, but other than that, it looks pretty good.
Yeah.
Like it. Domain, you it's not going left forever, right? How many gallons of gas can you put in the gas tank?
What was that?
How many gallons of gas can go in the gas tank? Like what's the minimum amount you can put in? What's the maximum amount you can put in?
12 is the max.
Okay. And you actually could put 12 in. What's the least you could put in?
Just like 1.
You actually don't have to put any in, right? You put no gas in, doesn't cost you anything. I mean, it'd be silly, right? Why would you go to a gas station? But maybe you show up
Yeah.
and you left your debit card and you don't have your phone with Apple Pay on there, whatever, right?
Mhm.
Pumps are closed.
Mhm.
There's all these options. Now the range is like how much you pay. So what's the least that you can pay? And again, think about, what is this bottom point? What is this top point?
Is that 30?
Yes, the most you can pay is 30 and the least you can pay is
Is 0.
0. So this problem is really like the other piecewise graphs that we've done. They're just the ones like, it's like you got to graph it, maybe you write a function, give a domain, give a range. What you should be looking for is the commonalities between questions, like what's the same, what's different between them.
Okay.
All right. Any questions on that before we move on to number 1 on the other side?
I don't think so, no.
Okay, I'm happy to make some problems like these. I don't know how long they'll take. Our lessons are 50 minutes, so we got 29 more minutes, and we'll probably get through these. So let's take a look here. An apparatus designed to study simple harmonic motion.
I was like confused.
Yeah, no, I noticed you changed seats.
Yeah.
I saw you were sitting there, so I just thought I'd check see if you
Yeah. I'm sorry, what was that?
Yeah, just let me know when you're ready. Happy to
Oh, I'm
continue.
ready.
Okay. An apparatus designed to study simple harmonic motion. There's a mass attached to string. So this is the mass, and there's a spring attached to it. And the idea is like if you push it to the left or you pull it to the right, it'll start bobbing back and forth. Maybe you saw that in a physics class, or maybe you've seen that at some point. They're saying the position is determined by this right here. Okay. And they're saying to graph the model, labeling the axes, and all this really is you graphing this trig function right here.
Okay.
But it's probably been a while since you've done it. You need to identify a few things. One thing that you need to identify is the period. The period is 2 pi over b. What is b? B is the number in front of x. So in your problem, B is pi.
Okay.
The reason you need the period is because when you graph this thing, you have to start and know how far out to go. So 1 period is 2. I'm going to just take a few liberties here with scaling. I'm going to call that 2 and that 1. Okay. And then what I like to do is I like to first just graph a cosine. So if you remember what a cosine looks like, it starts high, goes low, and comes
Mhm.
back high. Do you remember that?
Yeah.
And so there's 5 critical points. There's, okay, it starts up here, it goes down, it comes down, it comes back up, it comes back up. So this was covered in a previous part of the course, hopefully, or
Yeah.
course last year. And it keeps going forever. Okay, you don't have to um, graph it forever, but you might want to check with your instructor, like, hey, how many, periods should I graph? Like sometimes they're like graph 1 period or graph 2 periods and so on. All right, now we have not taken into account the amplitude. The amplitude is the absolute value of the number in front. So it is 15. And what that does is it pulls the graph up. Like this point, like if you want to think of that as 1 and this is -1, it pulls it up and down. So I don't have room to do 15, but just presume that's 15, and then that's down here. This is -15 roughly. It gets
Mhm.
pulled, these points get pulled. Something like that.
Yeah. Okay.
All right. Now what you're noticing is that the distance is a maximum from the origin at 0, at 1, and at 2. And that's kind of what we're gonna look at next. Maybe we've actually already answered some of those questions. I don't know, let me know if you need more explanation. Graphing can be very difficult if you've not seen it in a while, or it's not clear what we're doing.
No, I understand. I just don't know if I need to like add like any like numbers like where the dots are.
Yeah, that's a good question. I mean, we can label those. This is 1 -15. This is 2, 15.
Wait, how'd you get 1 -15?
Just that point gets pulled down. Like it's the black one is the parent function. And so
Oh.
that parent function point is a known point.
Mm-hmm. Oh. Does that have to be added onto the graph?
I mean, your instructor gives you so little room to graph this. I don't really know. Maybe they just want like this one up here where it's like 0, 15 and 2, 15 and 1 -3. Like, I don't know. They might be okay with just that.
Yeah. Okay. So is that it for it for the graph?
Yes,
Okay.
that is it. Okay, now the next question here, which is how far, let me see if I've got the, yeah, how far do the students move the mass away from equilibrium? That's asking for the distance from this center line to the peaks. Okay. Basically, it's a distance of 15.
Okay.
We don't know the units. Like normally they would tell you it's meters or inches or something. We don't really know. But it's
So,
essentially the distance from the center line to the top.
so just like the amplitude kind of.
It is the amplitude. It's exactly what it is. It is exactly the amplitude. It's the absolute value of 15, which is 15. Good. Okay, part C. It says, how long does it take for the mass to return to where it was released? That's the time it takes for it to drop down and come back up. It's the time right here. And we saw that started at 0 and ended at 2, AKA this is the period, right? Like the previous problem was the amplitude, this is the period.
Mm-hmm.
All right, any questions on that before we move on to number 2?
So it's just like 2.
It's just 2.
Okay.
It's the distance along the x-axis until it gets back to where it started.
Okay. Got that.
All right. Okay, let me grab number 2, although I think number 3 might be similar. All right, mass is hanging from a spring attached to the ceiling of a classroom. Student pulls down on the mass and releases it. The mass's height oscillates with its height taken from the ceiling. The highest the mass travels is -10 centimeters. The lowest is -16 centimeters. Students measure the period of oscillation as 3 seconds. Graph the situation labeling axes. Okay. It might be good to use the information to go backwards and figure out the equation.
Mm-hmm.
It's kind of like on the previous side, you have one problem going forward, the other is going backwards. The period's a good place to start. The period is 2 pi over b. They're telling you the period is 3. And you have to solve for b. So to do this, do you remember how to solve for something in the bottom?
I haven't really done it like this. Would it just be 6 pi?
So let's just do something maybe I'm doing right. Let's cross multiply 3 times b equals 2 pi times 1.
Mm-hmm.
And then you divide both sides by 3. So b equals 2 pi over 3. The reason you need that is that in the kind of the a cosine bx equation you're using here, it's really sometimes other variables. It's actually, let me write it differently. You guys are doing it this way. A cosine omega t. B is really that w there. I know it's weird, awkward,
Mm-hmm.
but talk to your teacher. Ask them why you're doing this. This is out of scope for your course. Nevertheless, okay. The amplitude you find, it talked about, it's like you start at -10 and it dips down all the way to -46. So there's a center line here. The center line is the average of them.
Mm-hmm.
It's the average of -10 plus -46 divided by 2. Will you calculate that for us, please?
I got -33.
-30. -28.
Oh. Really?
56. Yeah, -56. What's them? Yeah. If to add them up, this is a 10. I'm sorry, maybe my handwriting's not very good. -56 divided by
Oh, I
2.
got.
Yeah,
Wait, how'd you get -56?
just adding the two numbers together there. -10.
Oh yeah, I got that. I think I put a different number in.
Yeah, so you got -56 divided by 2 is -28. The other thing that you need is this distance here from the center line to the top or the bottom. That's the amplitude. And so it can be a little bit awkward with negative numbers. You just need the actual distance. Like you don't need to worry about whether it's positive or negative. You just need, well, how far is it?
Mhm.
And you can see that it's 18. There is a formula for it, which I don't know if will help. I can give you those at the end.
Mhm. So when it says to graph it, is that
Yes,
just what you?
we're gonna get to it. I'm just trying to, we gotta like put all this stuff together. Because we're gonna need the equation. And I mean, that's part B, but it's easier to kind of graph from the equation.
Yeah.
All right. So the equation is, there's a little bit more to it. It's A cosine omega t plus this vertical distance d. So the A is that 18 cosine 2 pi over 3 d, and then that center line goes here.
Mhm. What does D stand for?
D is the center line. It's the vertical distance that it kind of starts at. Usually it's 0, like in the previous
Mhm.
problem it was 0, but this one they made it more difficult.
Okay.
So now we can graph it, which isn't great, but it's, you know, like a lot of times we're really comfortable with, okay, that's 0. And it's like, yeah, it's down here at -10 minus what was it, 46. Sorry for all the scrolling. And then minus 28. So what it does is it's the same shape as before.
Mm-hmm.
And we know that it takes 3 seconds to get there.
Yeah.
And then the middle one is 1.5.
Wait, where'd you? Okay, never mind. Got
Just
it.
right in the middle.
Okay. And is that all you have to do for the graph, or is there something else?
Nope, that's it.
Okay.
All right. So now we've kind of already done part B, kind of. I mean, the model is the equation. It's, again, sometimes I do things out of order because it's easier to graph the model, but the model is the A cosine omega t plus d. You know, you might be using different letters, but W is that period, or it leads to the period. Sorry, let me write it differently. 2 pi over W is the period. A is the max minus the min divided by 2, and D is the max plus the min divided by 2. So if you go back to the numbers that we're using from -10 to -46, I know they're negative, but if you were to go -10 minus a -46 over 2, you would get the 18. And like we did before, -10 plus -46 over 2 gets you the -28.
Okay. Makes sense.
All right. All right, so let's look at number C, part C. When the mass was at rest before being pulled, what was its height? So that's the center line. That's the D value.
Oh,
Okay.
So is that just negative 28?
Yes. Or you might say 28 centimeters below the ceiling.
Okay. Okay, I got that
All right.
one.
All right. So number 3 here, another equation. I mean, it looks like you guys are, you're going to get one problem graphing piecewise or writing a piecewise and one sort of harmonic motion. So they're just giving you another situation. Really, the thing to focus on is this right here. Okay. And it'd be nice to kind of label all the stuff like, what is the 40? The 40 is the amplitude.
Yeah.
So the amplitude is 40. The 50 is the center line. It's also called the vertical shift.
Mm-hmm.
That's kind of right where it is. And then the
Okay.
period, this is the one that I think is low because it's not the number, it's 2 pi over W. And in this
Mhm.
case, W is that pi over 50.
Yeah. So would the pies cancel out?
They
by
they
that?
do, but you got to multiply by you got to multiply by the reciprocal. So unfortunately, it doesn't quite cancel out here. You multiply the top and bottom by 50 over pi, 50 over pi. So they cancel out there, and then they also cancel out in the top. It just ends up being
Okay.
and that's the period. So the period is the thing that's really helpful about the period is it kind of tells you where your graph goes out to. You know that it goes out to 100. Like that's where it finally repeats.
Mm-hmm.
Okay. The center line kind of tells you where to start. So this is obviously not to scale in anywhere, shape, or form, but if you can imagine, like the center line being at 50, that's at 50, the graph's going to oscillate above and below that point. So it always goes up the amplitude,
Mm-hmm.
and then it goes down the amplitude, which is at 90 and 10. And I got that number comes from A. A is 40. So it's like you up 90, down 90, and
Mm-hmm.
it gets back to that same point. So it goes down, comes back up like that.
Okay. And you know it's starting at the max because it's a positive number.
Well, it says it says that it's starting at the top of a fence.
Oh, okay.
That's kind of the key word.
Okay. That makes sense. Um, Is there any way you could like give me an example of like a piecewise function? Because I want to like practice the domain and the
Yeah.
range.
Let's do this. Let's say I give you something like this. This is f of x, and I say it's minus x plus 3 for x less than -2, and it's 4 for -2 less than or equal to x less than or equal to 1, and then x plus 3 for x greater than or equal to 1.
Okay. So can I just like get the domain like from looking at
Kind of. We would also want to do range on this potentially, so I'm not sure if you want to maybe try to graph this
okay.
at least a few points.
How would I graph the second one?
So the way to think of it is y is always 4. And if you're making a table, it's like saying, okay, -2, -1, 0, 1, but y is always 4, 4, 4, 4, 4.
And what do I do with like the second, like the -2 is less than x, less than or equal to 1?
I'm sorry, which one?
Like when it says -2 is less than, and then the one
X
on the
less than
top,
negative, X less than -2, this one here, or the one below it?
the one below it.
Okay, the middle one, it means between. It means X is between -2 to 1. It's only good for
Oh,
-2 to 1.
oh, okay. So how do I graph? So would I just put a 4 and like
You,
not worry about that?
well, you graph those points on that table on the right, like, and then you connect them. It looks maybe more
Oh,
complicated than it actually is.
oh, okay.
I'm happy to, I'm gonna graph it here, but I'd like you to give it a shot before we start.
Could you graph it? Because I don't know if I did it
Sure.
right.
Sure. So the -2, the other kind of way to do it is kind of create this like break at -2. It'd be like, okay,
Mhm.
at -2, when I put that in, that's 5. So -2, 1, 2, 3, 4, 5. Barely got enough room to do this. Let me just shift all this down a little bit. Actually, let me just shift this down. Okay, -2, 1, 2, 3, 4, 5. So there's like an open circle there, and then it's coming down. So it ends up looking something like that. Does that match what you have for the first one?
Mhm.
Okay, now the 4 from -2 to 1, it's just this, just a straight line like that. And then x plus 3 greater than 1, it actually, if you make a table for that one, x, y, 1, 2, 3, 4, 5, 6, like that.
Okay.
Now let's talk about domain, because that's what you're asking about, domain. You can get it from the piecewise, like you can get it right here. You don't have to graph it, but I was going to say, let's do range as well. How far left does it go? How far right does it go?
Um. Uh. Is
Like
it
how,
-2? I can't tell what that number is.
well, remember, it goes to the left forever. That that line means it goes forever to the left. I know it goes up, but it also goes to the
Oh,
left forever.
oh, okay. Um. So what would I say for that?
Minus infinity to infinity. That means left forever
Mm-hmm.
and right forever. Like, try not to focus on the gaps in the Y, just see like how far left does it go? And how far right does it go? In any place in between, you're overlapping that filled in one overlaps with that non-filled in one.
Mm-hmm. Oh, okay.
You want to think a domain is left to right. Left to
Okay.
right. All right, and range here. So what's the smallest Y value that you see? Yeah, these go up by ones there.
The smallest. 1.
There's nothing here at 1.
Oh,
Like,
oh,
what
4.
is this represented by?
Just 4.
4. So it starts at 4. And then how far up does it go in each direction?
Like it just keeps going.
Yes, so that's infinity. Okay, and then bracket, parenthesis, the bracket because it's included. The bracket of your call means included,
Mhm.
and then the parentheses always go with that.
Oh, okay. Okay, that makes more sense. So for the domain, I just look at the graph and see if it like goes to infinity.
That's
If it doesn't, I see like the smallest number that it stops at.
right.
Okay. Well, I think that's it.
Yeah. Again, just kind of, keep in mind, there's probably one of each